if you take a look at the title of the set of notes, it's okay, and I'm going to tell you that this is actually a code for, well, I'll write it out. Okay, what this actually means is it means solving systems of equations. And you're probably like, oh, how does solving systems of equations mean? Well, there's actually a system that I use to make those words turn into a jumbled mess. Okay, this is the whole idea of this thing that I researched in grad school. I was really into cryptography, which is, well, the science of turning regular words into a jumbled mess so you can't tell what they are. Okay, and this is actually a really big field in mathematics. It started out, well, a long time ago, but it really started advancing around World War II. Okay, and one machine that was very widely used in World War II is this one. Okay, does anyone know what this machine is? It does look like a typewriter. It actually acts like a typewriter, but it actually has a special name. Did anyone watch The Imitation Game? It's kind of a while ago. It had Benedict Cumberbatch or something in it. All right, so that movie kind of explained, it was started out using this machine, and this machine was called the Enigma. Okay, and this machine was used in World War II by the Germans or the Nazis or whatever to encode messages to be sent between them so people couldn't intercept it. Okay, so whenever they sent a message like, hello, this boat is going to go over here, they didn't want the Allies going and figuring out, okay, that's the message that I sent. So they would type it in this machine, and this machine would mix up all the letters in that message and make it look like a jumbled mess like that, so the Allies couldn't figure it out. So there was this whole idea of, well, in mathematics of, okay, how do I take a message that's all jumbled up and figure out what it means? Okay, so does anyone actually know how they figured out how to decode it in the first place? Well, I guess if you don't know what the machine is, you wouldn't know that, right? So basically, every German message, it was really simple. It had a very big format, and I think it always started out with like Hail Hitler in it. So every single message started out with Hail Hitler. So they realized that, well, okay, the first couple letters in all of these messages were always the same couple letters. So they were able to piece together, okay, I know that like A actually means B, or I know that C actually means F. And they were able to take that information, guess what it meant, and actually turn it into decoding all the messages. They created this huge computer. I don't know if you've ever heard of the mathematician Alan Turing. Okay, he was really big into computation, really extended the field of computer science. And he really did a lot with being able to intercept messages like this. And he actually kind of made this machine to undo the Enigma. Okay, he was a British mathematician. In the US, there was this person named William Coffey. Okay, William Coffey, he was in the US, he was hired as a janitor, okay, at the NSA, before it was called the NSA. And he actually became like the deputy director of the NSA by the time he finished his career. So he went from a janitor, he was really good at like crossword puzzles and undoing those things. And people realized that he was so good that they promoted him all the way up to deputy director of this like huge governmental corporation that there is now. So mathematicians have worked with these sort of cryptographic messages, uncoding messages their whole lives. I did a little bit in grad school, and honestly, it messed with my head a lot. And one thing that I worked a lot with in grad school were these things called systems of equations. Okay, you've probably seen something like this in high school, where you were given two equations. okay, like y equals mx plus b and another y equals mx plus b, and you were asked to figure out, okay, what value of x and what value of y fit this equation. Has anyone seen something like this before? Yeah, right? So the whole goal of when you're given two equations is you want to find not just x, but you also want to find what y is, right? You want to find both values that fit the equations. Now, if you're dealing with cryptography, there's a very special sector of decoding messages where you're not just given two equations and asked to find x and y, but you might be given 10 equations and asked to find a, b, c, d, e, f, g, h, i, and j. Right? So there's a huge field in mathematics. It's actually called linear algebra, where we expand these systems of equations. It's not just two equations, it's like 15 equations, and you're asked to figure out, okay, what are all the variables that fit these 100 equations, and so on. And that's kind of how the Enigma worked. And that's why it was so hard to be able to decode this. And that's why these two people are very, very smart, and I don't know how they were able to do this. But for now, what we're going to do is we're just going to focus on simple systems of equations. We're just going to be working with two equations, and we're asked to find two variables because that's hard enough. And then maybe one day we'll be able to solve those huge equations. Maybe. I don't know. Probably not. Okay. Well, I'm going to give you a few different ways that we can use to figure out, okay, how do I solve a system of equations? And we'll talk about a systematic way to do this more algebraically after we look at this example, okay? So if you're ever given two equations and you're asked to solve it by graphing, the strategy we're going to use is, well, first we're going to, oh gosh. First, we're going to graph the equations. Okay, and once you graph it, well, those two equations plot all the points where all things work for those equations, okay? So when those two equations intersect is actually the solution to the equation. So once you graph the equations, you're going to see where they intersect. Okay. So why don't we do a small example here, okay? First, we have two equations here. We talked about graphing them on Wednesday. If we look at the first equation, this is good review for the quiz. What's the slope? I think I heard it. It's actually 3. Yes, it's 3. The slope is the one that's attached to the x value. So the slope here would be 3. I like to write personally 3/1 to make it like rise over run. So it's easier to graph. And that means the y-intercept would be 4, right? Because that's the other one. Okay, so if I went ahead and graph this equation, usually what we do is we start at the y-intercept. Okay, and then we can use the rise over run to sort of, well, plot the other points, right? Well, if I do rise over run, it tells me I need to rise 3, 1, 2, 3, and run 1, right? Well, that's not very helpful to me because, well, now I'm off the graph and I don't really like doing that. Any other ideas on how I can plot another point on this graph? Yeah, right. We can go the opposite direction. So the reason we can always go in the opposite direction is because, well, instead of like moving a negative sign, I can add two negative signs and they would cancel each other out, right? So another way of saying 3/1 is -3 over -1, right? Because the negatives cancel each other out, okay? Which means, well, I can rise down 3 and run to the left 1, and it looks like I have a new point on my graph. All right. Now you can be more detailed than me. You can draw more points. Once you have 2 points on a graph, you really don't have to draw anymore. You can just connect the dots and make your own line. Okay. So we graphed the first graph. Let's do the other line. Okay. Well, if I took a look at the second line, I know that that slope is still the same. the slope is 3. This time the y-intercept, oh gosh, I can't spell, is -2, right? Because, well, we're subtracting off 2. So if I were to graph this line, I would start at the y-intercept where it intersects the y-intercept, oh gosh, the y-axis, which is -2. And this time I can just rise 3 and run 1 because I'm not going to go off the graph if I do that, right? I can go 1, 2, 3, and go over 1. Okay. So once I plot these 2 points, I can, of course, connect the dots. And it looks like this is what this graph looks like. All right. So in the beginning, I said, my strategy is I'm going to graph the equations and I'm going to see where they intersect. Wait a minute. Do these graphs ever intersect? No, right? These 2 lines are parallel, which means that they're never going to touch each other. And it actually makes sense because if the slope's the same, it means the steepness of the 2 lines are exactly the same, right? So that means these 2 are never going to touch each other. They're always going to run side by side. Okay, so there's no intersection here. Okay, so does this system of equations have a solution? No. No, right? There's no solution. Okay, so one thing that people, I think, forget a lot is when you're given an equation, you always think that there's an answer, right? Sometimes there's actually no answer. Okay, sometimes there's just nothing that works for it. Sometimes no answer is the right answer. All right. Let's, oh, wow. Okay. Did not mean to do that. Oh, you saw my cat up here, sorry. This is my kitty cat. I had to put her down a couple weeks ago. It was really sad. But she's still here. That's okay. Besides the point. All right, let's go to example number 2. All right, so we got 2 equations. This time it looks like the slopes of those 2 lines are different. So it looks like these 2 are actually going to intersect this time, right? Cool. Well, let's go ahead and graph these 2. If you want to get ahead of me, that is fine. The slope of the first line is -4, right? Because that's the number attached to the x. The y-intercept is 2. So if you go ahead and graph this, starting with the y-intercept, well, let's see. I can go up 4. 1, 2, 3, 4, but then I'd go off the graph, right? So another way of graphing this graph would be to go down 4 and to the left. Oh my goodness. 2, 3, 4, and go to the right one, right? Okay. So go ahead and do that. It looks like our graph looks like this. Okay, that looks like a very bad line, but you know what? Let me redo that. There we go. All right, if you go ahead and graph the other one, this time the slope is, well, what's the slope if there's no number in front? 1, right? But then it's a negative, so I guess definitely -1's that slope, right? And then we got a y-intercept of -3. Okay, so I'm just going to go ahead, plot -3, and then I just have to go down 1 and go to the right one, right? Because that's what my slope's telling me to do. Okay, so connecting the dots here, it looks like my graph somewhat looks like this. Cool. All right, this time it looks like my 2 graphs actually do intersect. They seem to intersect over here. Oh gosh, did not mean to do that. Here we go. Okay, let's figure out what the x and y values of this point is. Okay, what do you think the x value of that point of intersection is? Doesn't have to be perfect. Yeah, it looks about 1.5. And what do you think the y value is? Yeah, negative 4.3 sounds about right. Okay. So basically what you do is you find the point of intersection, you find the x value and the y value of that point, and that's actually a correct answer to this equation. Okay. Now, we can express our answer in multiple different ways. One way is to just list the x value and list the y value. Okay. Sometimes people like doing this. They'll put their answer in ordered pair form. So they'll put the x value in the x slot of an ordered pair, the y value in the y slot of an ordered pair. Sometimes it looks nicer to write your answer like that. I don't care which way you write your answer as long as you show the x value and the y value of your solution. Okay. Any questions on, oh yeah. At 2, -5? Wait, can I see yours? Do they really intersect at 2, -5? And I just didn't draw it very well. Maybe, yeah. Am I just a bad artist? Yeah. Maybe, I don't know. Oh, gosh. Yep. Well, I guess 2, -5 would be a point on that top line, because you have to go 1, 2, 3, 4. So I'm pretty sure that point wouldn't be on the blue line either. I think we're just not very good at drawing. Yeah, so when you're drawing like let's say we were drawing the green line, sometimes it's confusing to realize, okay, do I go right? Do I go left? That's why I kind of like writing the slope as a fraction, because then it tells me, okay, I can rise -1, so rise down 1, and I can run to the right 1 because, well, we have a -1 on top and a +1 on the bottom.
Oh,
Yeah.
okay,
Mhm.
that makes sense.
Yeah, I'm gonna say, honestly, I think I'm just a bad drawer in general. We're not very accurate here. So let's just say these are the answers. Honestly, they're probably not very accurate because I'm not that great of a drawer. That's all right. We'll have a more accurate way to do this coming up next. Yeah, I think having a ruler or like something really, really good might help us, but I'm just not that artistically talented. All right. So I know graphing is kind of weird. Sometimes you don't graph the line right, and well, it doesn't really end up giving you the perfect answer. There's actually a way more accurate way to solve these systems of equations by following these steps, okay? Now, if you've ever done this in an algebra class before and you remember how to do it, I just recommend going through your way of doing this, okay? I'm gonna show a very systematic way as to solve these systems of equations, because if you follow these steps, I can guarantee that, okay, you're gonna follow the same steps every single time and you're always gonna get the right answer, okay? If there's another way you wanna do this, go ahead, but let me show you how I do it. Whenever we solve systems of equations, the first things you want to do is you want to make sure that, okay, if you focus on both the x values or both the y values, those two values are, well, going to be the same, but they have opposite signs. And if that doesn't make sense, just wait till example number 3, okay? After you do that, if you add together the two equations, those two variables are going to cancel out, and then you'll have an equation with one variable, okay? And then step 3 is solving for the other variable. I know these steps don't really make sense right now, so let's just do an example where we follow these steps, and I promise you it'll make a lot more sense. Okay, the first thing I want you to do on example number 3 is I made a typo. There should be an x after the -16, okay? So all these equations are gonna have x's and y's in them. Just put an x next to the -16. All right, let me show you what I mean by step 1, okay? In step 1, it says I need to focus on one of the coefficients, either x or y. And I wanna make sure that, okay, one variable matches the other, okay? So if I focus on the x's, we have an 8 and a -16, right? And if I focus on the y's, we have -6 and 7, okay? What I'm gonna to do is, well, they don't match, right? I'm gonna try to finagle with one equation and try to make it match the other. And if you don't see what I'm doing right now, okay, if you don't understand what I'm doing, it'll make sense later. I'm gonna take the first equation. I'm gonna do something weird. I'm just gonna multiply it by 2. The entire equation by 2. Okay, and if that doesn't make any sense, it'll make sense a little bit later. Okay, so when I say multiply the entire equation by 2, I mean take every single number in that equation and multiply every single number by 2. Okay, so let's see what happens if I do that. Okay, well, what does 8 become if I multiply it by 2? 16, good. And the -6 becomes -12. And then the -20 becomes -40, good. So I just took every single number in that equation and I multiplied every single thing by 2. Okay, now I didn't do anything to the other equation, so I'm just going to rewrite it. And I'm going to rewrite it in a way where all the variables are stacked underneath each other. So the x's are stacked, the y's are stacked, and the 30 stacked on the -40. Okay. Does anyone see why I multiplied by 2? Yeah, right. If you take a look at the x's, now we have the same number on x, but they have different signs, okay? So what you really want to do is by the end of step 1, you want one of the variables, either x or y, okay? So one of x or y, okay? You want them to have the same number. Okay, they have the same number 16, but you want them to have different signs. Okay, same number, different signs. Okay, here's what I'm gonna do next. Once I have the same number attached to either x or y with different signs, I'm just gonna put a little line underneath them, and I'm gonna put a plus sign next to it. So basically what I'm gonna do is I'm gonna add the 2 equations together, okay? So we do this just like regular addition. What do you think 16x minus 16x becomes? 0, right? That goes away. This becomes 0. I can do the -12 plus the 7. I'm not good at arithmetic in my head. That becomes -5, but it's still attached to the y. How'd I get that? Yeah. I looked at my notes. I can't do arithmetic in my head. I'm really bad at that. All right, and then we do the -40 plus the 30. I can do that one in my head. That's -10. Okay, so we're left with 0 minus 5y equals -10. Cool. Well, the 0 just is 0, so let me just rewrite this equation without the 0. We have 5y equals -10. Okay, how do I solve this equation?
You need to divide -5 on both sides.
Perfect, right? So the next step would be, okay, I need to take -5, divide it on both sides, and then, well, we have y equals -10 divided by -5 is 2. Okay,
Because the negative cancels out, right?
yes. Okay, so once we're here, we've actually finished step number 2. We finished adding together the equations and solving for one of the variables. But whenever we're given a system of 2 equations, there's not just one variable that's our answer. We actually have 2 answers, okay? So I found out what y is. I actually need to go back and figure out what x is, okay? The way we go about doing this is if you take a look at your systems of equations, you have 2 equations, what you're going to do is you're going to pick one of the 2 equations, either the first one or the second one. It doesn't matter which one it is, okay? What really matters is which one looks easier to plug 2 into, okay? Which equation looks easier than the other? I honestly think the first one's easier, but we can choose the second one. Okay. So I'm just going to go ahead. I'm going to do this. I'm going to write out, we're going to pick the second equation. But I'm going to write a little note. It doesn't matter which equation that you pick. Okay. So it doesn't matter which one? Okay, that second equation says negative 16x plus 7y equals 30. Okay. What you're gonna do with that second equation is you're gonna take your previous answer, y equals 2, and you're just gonna plug that into y. Okay, so whatever you got in that last step, just plug it in. And we have negative 16x plus 7 times 2 equals 30. So I just plugged in 2. Okay. Not too bad, right? Okay, I know that I have 7 times 2. I know those multiply to be 14, right? Okay, and now we have something that we can solve for x, right? Okay, a lot of stuff going on here. What should I do on both sides first? Should I undo the 14 or the negative 16? Undo the 14 first, right? Because the 16 is kind of attached to the x, the 14 is off to the side. So let me just subtract 14 because that's the opposite of addition. Okay. On the left-hand side, we're left with negative 16x. On the right-hand side, we're left with 30 minus 14 is 26. Is that right? Hopefully. Is it really 16? Oh God. This is why I do not like arithmetic.
It's okay, use your calculator, it's okay.
Yeah, when I was in elementary school, I hated math so much. I thought math was all like subtracting and adding. I was so bad at it, and some of my classmates could do like really like complicated stuff in their head. Like they could add like hundreds of numbers together, and I just felt really dumb. But later in life, I realized there was more to math than just adding numbers together. So it turned out a little bit better for me. But elementary school me would not imagine me teaching math. I would be very horrified at myself. Okay, once we're here, all we have to do is divide, right? Divide by negative 16. And it looks like x is left by itself. And on the right, we have negative 1. All right. So that becomes the second part of our answer. Okay. Now, you can either leave your answer like this, just circle y equals 2 and x equals negative 1. We can also write our answer as an ordered pair because, well, we're dealing with data that has 2 things in it, right? So if you really want to write your answer in a nicer way, you can write the x value first and the y value second. And that becomes your answer. Okay. Any question on what I just did here? I know there was a lot going on, but I think, yeah, so I'm gonna switch this to test 2. So this isn't gonna be on test 1, but maybe the next one. All right. Flip our page over. I actually wanted to go through one more with you guys before I let you try one on your own.
Oh, so we're gonna take the quiz today?
Oh, shoot. How do you guys feel about taking the quiz now?